Well, neuroscience is the science of the brain, but I think it's important to realise that there's lots of different types of neuroscience. There's like molecular neuroscience, but there's also cognitive neuroscience. And cognitive neuroscience is the neuroscience which is of greatest interest to education, because that's about the link between the brain, the mind, and behaviour, and that can include learning behaviour. So when I talk about neuroscience, I'm usually talking about cognitive neuroscience. If you think about attention as a cognitive neuroscientist would think about attention, you can think about attention to some extent at a behavioural level, because there are certain things that we do when we're paying attention. So eye gaze, for example. I will be looking at you. I'm more likely to be looking at you if I'm paying attention to you. But then underneath that, there are mental concepts. There are things that are in the mind. And the mind is like a theoretical thing that we can't touch. So I'm possibly, thinking this is, what Bruce is saying is interesting. I'm gonna look over there. So we are aware of the contents of our mind, the conscious aspects of it anyway. But it is theoretical. We can't touch it. But then we assume that actually that relies upon a biological substrate, our brain, in other words. And one important thing to realise is that actually there are bidirectional links between these. So the brain is going to be influencing my ability to pay attention, but actually where I put my attention is also going to be influencing the contents of my brain. And so there's like bidirectional links between the brain and the mind, but also between the mind and our behaviour. So there's lots of neuromyths that we can look at that are very popular in schools. I mean, the most popular one, I would say, is learning styles. The idea that because our brains are all different and we have a visual cortex and an auditory cortex and a sensory motor cortex, then we can actually be categorized in terms of we're visual learners or auditory learners or kinesthetic learners. And that is somehow going to, our learning is going to be improved if the teacher teaches to our learning styles. And actually, it is true that we have preferences in terms of how we like to receive information, be it visual, auditory or whatever. But unfortunately, there's very little evidence to suggest that teaching to learning styles can improve our learning. I mean, other types of myths would include drinking water to improve our academic achievement. There's lots of examples on BBC Online about stories of how installing water coolers in schools have raised standards of achievement within a school. If you're thirsty, it's true that you can think a little bit more clearly if you've had a drink of water. So dehydration can reduce our ability to think and to learn. But actually, in a temperate climate like the UK, really you don't have to monitor water intake all the time. The only exceptions to the rule are when you're taking exercise or if it's unusually hot. So sports days are a good example of when teachers need to monitor children's water intake. But generally, we drink water when we're thirsty, and drinking more water is not going to make us more clever. It's not going to help us to learn more effectively. So off the top of my head, I can think of 3 reasons why we should be thinking about neuroscience in education. I mean, the first thing is there are already ideas about how the brain works and ideas about brain-based or so-called brain-based education in schools. And a lot of these ideas are misleading. We have a lot of neuromyths in schools. So one reason why there should be an authentic dialogue between neuroscientists and educators is to help dissipate and get rid of some of these misunderstandings. The second reason is that we are having insights about learning from neuroscience. I mean, neuroscience is a very rapidly developing area. And as we understand more about the processes involved with learning, so we are getting some new ideas about interventions in the classroom. And so, 3 or 4 years ago, the Wellcome Trust in the UK, for example, with the EEF, funded a £6 million programme to research the effectiveness of some of these interventions in classrooms. But actually, I think the most important reason why we should be thinking about neuroscience, and not just neuroscience, but psychology and the sciences of learning generally, is because at the moment we lack a progressive scientific body of knowledge that can support how we teach and learn in the classroom. We can assume that all teachers, when they go into the classroom, have ideas about how learning occurs. If that was not true, then they would never be able to adapt their lessons effectively. It makes sense that that should be informed by our latest understanding of learning processes. And we've been a bit slow generally. I think the world generally has been a bit slow in incorporating some of the insights and understanding from science into our approaches in education. And in fact, in the University of Bristol, in this building now, the School of Education, we do now incorporate the science of learning into our teacher training. So there's lots of evidence to suggest that different approaches in the classroom can be more effective than others. I personally have been working on an intervention that looks at the effects of uncertain reward. So we don't yet know what the results of this intervention will be. But it is apparently, from our lab studies, shown to be more motivating if you get offered an uncertain reward than a certain reward for answering a question. So an uncertain reward is when you basically say, if you're correct, then we'll spin the wheel of fortune to see what you win. Whereas a certain reward would be, if you're correct, then you get a point. Now, one of the problems with scaling this up and putting it into classrooms is that actually any intervention it depends on the teaching approach of the teacher. So it's actually very difficult to assess these things using randomized controlled trials in schools. So my preferred option is really to treat the teachers as the experts and say, look, these things appear to work in the lab, so we're beginning to understand more about the underlying learning processes. These may or may not be useful to you in different contexts, and really to treat the teachers as the experts and make sure that they're enriched with this new knowledge that's coming from neuroscience and from the other sciences of learning, so that it's actually empowering teachers rather than just providing a list of prescriptions of what they should do in the classroom. So I think as we go into the 21st century, we can expect to see a lot of ethical issues arising from science, and education is going to be affected by those advances like every other field. So one example would be the use of cognitive enhancing drugs like Ritalin, otherwise known as methylphenidate. Now, this is a drug that's usually used to control symptoms of ADHD, but students without ADHD, and particularly university students, I'm thinking, often take this drug as a means of improving their attention around exam periods, as a means to enhance their examination grades. Now, this is something that's been developed through neuroscience, if you like. The use of cognitive enhancing drugs is likely to increase in future years. How, as educators, do we feel about that? Because it really challenges what we think education is about. Is it about just achieving the exam grades? Or is it actually, is it the case that an exam grade achieved with a drug is not worth the same as an exam grade achieved without it? And I think actually a lot of the ethical issues that we're going to come across in neuroscience with relation to education are going to revolve around this idea of agency. So another enhancement that you can buy on the internet now, although I'm not recommending it, is transcranial electric stimulation. So putting certain types of electrical signals across the scalp appears to improve our ability to learn. And I have colleagues, who are experimenting with this at the moment with children who have learning difficulties in mathematics, and it appears that their mathematics learning ability increases when they're wearing a magic hat, if you like. But the problem with this is that it doesn't really include the agency of the child. It's not like the child understands how they're getting better. They're not getting better as a result of better education and from learning new strategies or new approaches. This is something that's slightly removed from the agency of the child. Another example would be infant screening. So we have neuroscience techniques that can detect the likelihood of a child developing dyslexia later on in life as a result of an EEG measurement that's taken at birth. Now, how do we feel about labelling children at birth in terms of their educational potential? There's all sorts of questions that are raised here. Most of them, I think, are around interventions and ideas and developments that don't involve sufficiently the learner's agency. I think every development within science and technology can be applied in different ways. So it's kind of like saying, is fire good or is fire bad? Well, of course, it depends on how you use it. And it's the same with technology, it's the same with neuroscience. So there's a danger that the authority of neuroscience can be used to provide prescriptions that are not really suitable, or maybe not whole solutions in terms of what happens in the classroom. I mean, I don't personally believe that we can tell teachers exactly how to teach. And therefore, if we have interventions arising, with this sort of shiny covering of neuroscience, they're going to become very popular, and almost we could be setting off a new range of neuromyths by suggesting that because these have been developed with the help of neuroscience, they're going to be fantastic. So there is a danger, I think, that neuroscience can inappropriately displace the expertise and understanding of teachers. The real great advantage and the real positive hope is that actually by providing teachers with this knowledge and understanding, they will become more empowered. They will be in a better situation to be able to make good decisions about learning. It will help professionalize teaching further. And it will result in better learning because teachers are able to make a more critical, more scientific approach to understanding why learning is occurring or not in their classrooms and be able to do something about it. So yeah, I think there's some big discussions to be had here, and with any new science, with any new technology, we have to think very carefully about how it should be used for the benefit of everybody. So I think there are voices coming from various directions who are sounding objections to the idea of neuroscience being involved in education. I think the arguments are different depending on which group of people you're looking at. I think there's concern amongst some educators that this is another fad. To those people, I would say, if we have authentic engagement between neuroscientists and educators, that will actually reduce the likelihood of it being misinterpreted, and actually, and reduce the likelihood that this is going to produce more neuromyths. And really, we can't ignore this because the rate at which neuroscience and our understanding of learning is accelerating, it doesn't make sense for that not to be informing education, especially when we already have ideas about the brain being applied in the classroom, and we already have interventions like for ADHD that teachers have to deal with on a daily basis involving drugs, pharmacological drugs. So I think that those are genuine concerns, but we need to listen to them and we need to be thoughtful about that. And the more we involve educators in the dialogue, I think the more that those concerns, those critical voices, will actually be a benefit to the outcomes. But then you have other types of researchers. So I think there are some psychologists who believe we don't need neuroscience, that actually all the findings that are most relevant to educators come from psychology, and neuroscience is just putting on some sort of sugary coating on top. I mean, to those people, I would say, look, actually, psychology has not really impacted on education in the way it should have been. I mean, it's been over 100 years since we've had effects known like spacing effect, that learning is better achieved in blocks that are spaced apart rather than all together. But where is the impact of these psychological ideas? These psychological concepts are often quite abstract. And as for concerns from psychologists that neuroscience might be spreading neuromyths, we've also got enough psychobabble coming through in education already. So and it doesn't make sense because actually neuroscience and psychology are now informing each other more and more. It's where we see results coming through from neuroscience and from psychology that agree with each other, that we can feel more confident about those concepts. So really, neuroscience and psychology should be working together. This is not a competition to see who has the best ideas, because actually the best ideas are going to be drawing on both of those areas. Then we have some philosophers who think there is a category error in terms of neuroscience in education, because actually learning, they say, is not so much about the brain, it's about the mind. But the problem with that argument is that this is about a long-running philosophical debate around the relationship between the mind and the brain. And when we look at things from a scientific point of view, the cognitive neuroscientists would say, actually, it doesn't make sense to separate the mind and the brain when you're talking about human behaviour. These are two distinct concepts, but they are very much interrelated with each other. And therefore we should be considering both when we're thinking about learning. So that's the scientific point of view. And I think also there's always a certain wariness about anything new. And you have to remember that, education, development of ideas within education has not always been that rapid. There's some quite entrenched opinions, views and perspectives. And I think neuroscience is often seen as a threat to those. I think the big challenges for the scientists are to start moving their experiments towards looking at contexts that are more complex, more like what happens in the classroom. So at the moment, we're looking at learning processes inside a brain scanner, when really, ideally, we should be looking at those processes occurring as they are in a classroom. We are getting more mobile, more portable means of measuring brain function. So maybe that's an option for the future. For education, I think the challenges are to engage with the neuroscience, engage with the scientists, find what in this area is of greatest relevance, how to communicate it effectively, and really to embrace what's happening in terms of the advances we're making, in terms of understanding learning, but embrace that knowledge with the collaboration and involving the expertise of educators themselves, and most importantly, the teachers.